Hi, I'm Ridhwan. So I want to explain about project background. So our project background is Nature Sdn Bhd specialist in supplying renewable energy source such as electricity. So Nature Sdn Bhd took the initiative to reach out to people outside of the project. As a result, we developed the portable hydroelectric generator. This gadget is highly suggested for campers, hikers and kayakers who want to at least power everywhere.
Assalamualaikum and hi, my name is Ahmad Farid bin Mohamad and my matric number is B092010027. Now let's talk about the problem statement. In this problem statement, we built this hydroelectric generator because individuals may occasionally manufacture their own portable power source, such hydroelectric generators that use water flow to function as power banks when they visit parks with rivers nearby.
Hello, my name is Mohamed Fikri bin Nahar. My matrix number is B092010144. So, after we know the problem statement of this project, we should have an objective to solve the problem. The first objective is to encourage the usage of this device that produces at least 5 volts of electricity consumption using a multimeter when doing an outdoor activity in a day. The second one is to design a portable hydroelectric generator that can be used in a day by using SolidWorks. Then we continue to the project scope. So our project scope is to overview the current technology and innovation of portable hydroelectric generator. Then the user is for person that doing camping at the campus or outdoor camping. And then design the prototype of portable hydroelectric by using a SolidWorks.
My name is Khairunnisa Binti Hairul and my matric number is B092010128. I want to present about risk analysis, budget cost calculation, and project methodology. Health and safety risk is the sort of risk that our project faces. Refer to the table. There are 3 hazard identification, which are when measuring the river flow rate, holding the portable generator with bare hand, and using a hot glue gun. The first activity that have been discovered is measuring the river's water flow rate, which can lead to a risk like slipping on a slick surface. Sprain accident might happen as a result of the risk. The activity has a level 3 severity rating for moderate severity and a level 3 probability rating for something occurring as not or conceivable. The severity and likelihood of the danger are multiplied to get the risk priority number, which is RPN. Therefore, this activity's RPN is 9 at a medium risk level and it's still tolerable. By measuring the water flow in good weather and wearing sturdy shoes, it can reduce the danger since when it's raining, the riverfront will be soggy and will not be able to complete the necessary tasks to complete the project. The current risk control severity is at a moderate level of 3, its likelihood is at a distant level of 2, and it is RPM at a medium risk level of 6, which is still acceptable. Safer procedure for flow meter, which have a severity of 3, probability of 1, and RPN of 3. And as a risk management measure that is acceptable and at a low risk level. Team members are the ones who will be carrying this task. Repeat all the procedure to measure RPM with second and third hazard identification. Direct costs may be easily linked to a certain project, while indirect costs are expenses that cannot be immediately linked to a particular project. Based on the table, this project's total of direct and indirect costs is RM76.50. A fee will be also applied to any material required to complete the job. For this project, the cost of equipment and material based on the table is RM45.50. The charge incurred when travelling for work-related purposes are referred to as travel expenses. In general, when employees spend charges while travelling away from home exclusively for business activities, the firm may deduct reasonable travel expenses. That means the travel expenses for this project are RM20.50. In summary, this portable hydroelectric generator costs RM142.50. Project methodology. Phase 1. Analyzing the required water flow to make sure the fins spin effectively. Phase 1 will involve calculating the effective spin of the fin at different fin widths and fin spacing using the centrifugal flow of the water. The numerous tiny rivers in Malaysia may generate energy at least at 5 volts using small-scale hydroelectric plants. Phase 2. Investigation on designing the generator structure. In Phase 2, it will be focusing on the optimal consumption for the manufacturing, including a practical and generally user-friendly design for those who will be close to the water flow by utilizing solid work. Phase 3. Experiment, execution and validation of results. After then, the design will act as a prototype before being used by the wider public. The evaluation of the upscaling of the generator construction will be based on the experimental environment. Both prototype will be tested for their spec in order to get the best outcomes. Phase 4. Field evaluation of hydroelectric generator used to charge a boat. A field quality of portable hydroelectric generator make them quite useful while participating in outdoor activities all day long. The first was that since the portable power bank could be unplugged and shared anytime a phone's battery needed recharging, it was simpler to just keep it connected to the generator than to use the USB port to charge phone.
My name is Ulfa Syazwin, Binti Mohamad Sahabudin, and I will explain the expected result and discussion that we get from this project. This prototype was successfully assembled, and the result that we get is it can generate up to 5 V of voltage. It also functionally compatible with water flow, and it should be sufficient enough to generate electricity. But there are some problems when testing the prototype. The first one is there is a problem to connect the rod to the motor because of the size of the rod. And the last one is the speed of water flow rate is not enough to move the motor because it has certain speed to produce the desired voltage. Next, impact on environmental and sustainable development. For this project, we are referring to the 70 Sustainable Development Goals (SDGs) for portable hydroelectric generator. For this project, it was designed to mainly fulfill the Sustainable Development Goal 7, which is affordable and clean energy. The number of people with access to electricity increased by 1.7 billion between 1990 and 2010. And as the global population grows, so will the demand for cheap energy. Next, portable hydroelectric generator also indirectly supporting the sustainable Development Goal 13 by reducing the usage of coal-generated products that can lead to increasing the carbon dioxide emission to the atmosphere, such as many powerhouses and battery plants.
Okay, now let's talk about the conclusion that we got from the project. Okay, to sum it up, portable hydroelectric generator follow the objective that has been stated and complete within the time given. This project uses nature source to generate electric by using water. Without limiting the amount of water, hydroelectricity harnesses the energy of flowing water to generate power. The focus of the portable hydroelectric generator is effective in meeting user requirements introduced about hydropower and improving user satisfaction. It is more durable, waterproof, and easier to carry. So that's all from us, Group 3. Thanks for watching and bye.